let's take a look at another rational inequality. Again, the only thing you can do here is pull everything over and compare it to 0. So here we go. 2x minus 3 over x plus 5. Okay, minus 5 minus x over x minus 1. Now that can be compared to as greater than or equal to 0. Okay? Now, a couple things you might do. I'd rather this would read x minus 5 rather than 5 minus x. If I want to do that, it has to be at the expense of pulling out a negative. If I pull out a negative, then effectively I can make this positive. So then that takes care of that. Okay. The next thing I have to take care of is putting these on a common denominator. Okay. They need to be on a common denominator. At least I know that the common denominator can be the product of the two denominators. Therefore, I'm going to write this fraction with a denominator x plus 5 and x minus 1. The second fraction is also going to be revised to have that denominator as well. X plus 5, x minus 1. Okay, this one had the term 2x minus 3, but I introduced the x minus 1 as part of the denominator. I likewise got to do that up here in the numerator. So that'll be x minus 1. Over here, okay, I've got my existing denominator, which was x minus 5, but now that was multiplied by x minus 1. Let's put it on a common denominator. Likewise, I need to do the same up here. Still compares greater than or equal to 0. Now, I can expand this, put it on this common denominator, x plus 5, x minus 1. Expand this out by FOIL method. 2x squared is minus 1x, minus 3x, it's minus 4x, plus 3. Check that again. 2x squared minus 2x minus 3x is minus 4x, plus 3. Likewise over here, x squared. Of course, everything is addition here, so I'm safe. I don't need to put this in parentheses, although if that were preceded by a negative, I would. Okay, so x squared. And I get minus 1x minus 5x, which is minus 6x overall. And then looks like I'm going to get plus 5. Okay. All right. Let's clean up that. 2x squared, 1x squared is 3x squared. Okay, negative 4x and negative 6x is negative 10x. And 3 and 5 is 8. Okay. And now it's over x plus 5 and x minus 1. This is all greater than or equal to 0. Okay. Now, I'm not sure whether this is going to factor or not. The only thing I can do is try. So, let's see. 3x and 1x. 4 and 2. I think we got it. Okay. Minus 4 minus 2. Let's just double check that. Okay. That's negative 4x and negative 6x is negative 10x. Okay, we're good. X plus 5. And x minus 1 greater than or equal to 0. Let's just go back and check all the algebra. It's not a bad thing to do at this point. We brought this over. because we need to compare to 0. Okay. Now, all right, I didn't like the fact that this was 5 minus x. I would rather it read x minus 5. So I factored out a -1, which linked up with this minus sign to become plus. I then put them on the common denominator, which was nothing more than the product of the two denominators. Okay, and then I had to adjust the numerators, because if I'm multiplying by this fraction by a term in the denominator x minus 1, I must also do the same in the numerator. Likewise, in the second fraction, I had an x minus 1, I introduced an x plus 5 by multiplying it. Likewise, I got to do that in the numerator. My common denominator, x plus 5, x minus 1. Check my FOIL method again. First, outer, inner, last, 2x squared, okay, minus 3x and minus 1x is minus 4x. Last with last plus 3. Plus sign connects the two groupings. X squared minus 1x minus 5x minus 6x plus 5. Combine my like terms. 3x squared and 2x squared and 1x squared. Negative 4x and 6x, negative 10x, and 3 and 8. Okay, so we're good. Now we said that this factored, we were in good shape. It's negative 4x, negative 6x, combined negative 10x. All right, we're in good shape. Now let's build our sign table. We need to assure ourselves that x cannot equal 1 or x cannot equal negative 5. And we also need to include in our sign table the values which not only set the denominator to 0, but also those which set the numerator to 0. So if x were equal to 2 or x were equal to 4/3, they would be points of interest on my sign table. I'm going to take a break now, come right back to that. Okay, we're back. We're going to build our sign table. Going to take note of the values. Okay. Moving from left to right, the first strike we have is negative 5. Okay. Then looks like we're going to have 1. Then 4/3. And then 2. Negative 5 comes from the x plus 5 factor in the denominator. 1 comes from the x minus 1 factor in the x minus 1 factor in the denominator. The 4/3 comes from the 3x minus 4. And lastly, the 2 comes from the x minus 2. Now, notice that these numbers appeared as if they were on the x-axis, in order from left to right, increasing from negative to positive. Okay? What I'm interested in is what's going on left and right of each of these numbers. Okay? Not at these numbers, because I know each of these groups will be, each of these factors will be 0 at those numbers. Okay? Also, I put these factors in the same sequence going downward as their corresponding zeros going left to right. X plus 5 associated with the first here. The second factor here associated with the second number there, so on and so forth. When I do that, I can easily build my sign table. Very easily. I know x plus 5 will become 0 at negative 5. And left of that, it will be negative. And then in every group thereafter, it will be positive. Okay? Likewise, I know my x minus 1 will be, 0 at 1. I know left of that, it'll be negative. Throwing any values in this grouping, that is, any values up to 1, will assure me that this factor will be negative. Try it. Any values greater than 1, I'll be assured that that will be positive. 3x minus 4 will become 0 at 4/3. Left of that is negative. in these three groups, then I go to positive. Likewise, okay, 2, okay, will be negative, 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 then finally it switches to positive. Okay, so what am I interested in? Well, I got the product and or quotient of 4 negatives, which yields me a positive. 3 negatives and a positive yields me a negative. This is a positive, this is a negative, and this lastly is a positive. Okay? Now, what am I after? I'm wanting to know when this expression was greater than 0. Well, in this region, which is negative infinity to negative 5, now I can't include negative 5 because I made that claim up here. So I can't bracket that. I can put a parenthesis around that. My next positive group interval is from 1 to 4/3. I can't equal 1. So, but I can equal 4/3. So I'll bracket that. And the last positive group, 2, no problem with equaling 2. Can bracket that, and then I run that out to infinity. So there's 3 distinct positive regions, okay, meeting this inequality as well as the original inequality, okay? And that's how we got to proceed with that problem. No shortcuts. No shortcuts. Got to pull it over, compare it to 0, okay? Put it on common denominator. Simplify, grouping your like terms, foiling, whatever you need to do. Refactoring, getting your factors. All factors are accounted for in the sign table. One thing, had one of these factors canceled out, that'd be good. But then we would have to still account for it here. Say this was x minus 1 up here. You might want to cancel those out, which would be fine, which would streamline this sign table even more. But you'd have to keep this original claim that x can't equal 1. Okay? So bear that in mind. Okay? Notice the progression of signs here. Nice, nice, nice. Okay? All right? Don't necessarily think that the signs here alternate plus, minus, plus, minus, plus, minus. It won't always be the case. It will not be the case when one of these factors is squared, or one of those factors is always negative. Okay? Bear that in mind. All right? Notice the progression of signs here. Every step is an additional negative. If the sign table, okay, does not have anything peculiar happening, any squares or anything up in here, and if these numbers, if these factors are in line with these zeros down here, 90% of the time that's going to be the progression, but you have to line it up right. And it's still worth checking. I don't assume it's always going to happen, but in many cases it will. Okay, so just some things to bear in mind. Okay, hope that was helpful. Keep at it, and don't take any shortcuts on these things. These sign tables, very important for future reference with this course and as well as with calculus. Okay?